Hi dears, our subject is experimental techniques. It has been, we are studying in the third sem MSc Physics. Now we are dealing with the second module, thin film techniques. In this module, we have deal with the introduction, fabrication of thin films, and under that topic, thermal evaporation in vacuum, and moreover, the sputter deposition. Today, we can discuss the thickness measurement of a thin film by electrical conductivity measurement or electrical method. About thickness measurement. It is the most significant parameter of a thin film. All the physical properties of the film material is based on its thickness. Thickness monitoring during the fabrication of thin film is called in situ monitoring. The main in situ thickness monitors are Wheaton's bridge, electrical resistance monitor, and controller for metal films. The capacitor monitors are used for the insulator films. The most famous and widely used technique is the quartz crystal thickness monitor. In the electrical technique for thickness measurement, we have to deal mainly two types. The first one is resistance measurements and the second one is the film resistance by Wheaton's bridge method. In the resistance measurement method, it is applicable to metallic and low resistivity semiconductor films. The resistance is related to the film thickness and a mean free path of charge carriers. In the case of polycrystalline films, a thickness resistivity relation is useful for finding the thickness. This technique is more useful for the comparing the thickness of similar films rather than for absolute measurements. In this, the electrical resistivity of a metal and the semiconductor films can be measured other methods. In that methods, one method is in situ method, which has been developed by Van der Pauw in 1958. In this, both the resistivity and the Hall coefficient of metals and semiconductors can be measured. And in this method, using reciprocity theorem, he showed that if A, B, C and D are any four ohmic contacts arranged on the circumference of the film of any arbitrary shape, then the resistivity ρ in ohm centimeter is given by the following equation. In this, the Hall coefficient in centimeter cube per coulomb is given by RH is equal to, as per given in the equation, which is equal to mu h into rho. In this equation, T is representing the film thickness in centimeter and mu h is the Hall mobility in units of centimeter square per volt second. RABCD is the resistance between A and B when the current passes between C and D, and similarly. Delta R represents the resistance changes due to an applied magnetic field H in Gauss. Another most widely used technique to find the electrical property of thin films is Ford probe method. The resistivity in the range of 10 raised to minus 3 to 10 raised to plus 3 ohm centimeter can be measured using this method. A collinear 4-point probe with equal separation between the 4 probe points is used. The resistivity for a specimen of infinite volume is ρ is equal to 2 pi s V by I. In this, I represent the current passing through outer points, V the potential drop between the inner points with the spacing S. In this, to find the thickness for T much less than S by 2, we can rewrite ρ is equal to 4.53 Vt by I, or T is equal to rho I by 4.53 V, and The sheet resistivity of the film P by T is equal to 4.53 V by T. In this, the 4-probe setup for thin film thickness measurement is shown in the figure. V is the potential difference and S is the spacing between. The next method which is using as an electrical techniques for thickness measurement, that is the film resistance by Wheatstone's bridge method. It is applicable to the metallic films and low resistivity semiconductor films. Resistance of a thin film is related to its thickness as well as to mean free path of charge carriers within the material. An empirical thickness resistivity relation may be found experimentally to deduce unknown film thickness. And the resistance measurement is done by making the film in one arm of a Wheatstone's network. Here shows the Wheatstone's bridge circuit which is used for thin film thickness measurement. In this, S is representing the thin film for which the thickness is to be measured. It is included in one arm of a Wheatstone bridge. And the other R1, R2, R3 are the resistances and R2 is the variable resistance. For a given value of ratio of arms of the bridge, the film thickness is proportional to the variable resistance. The variable resistance can be set to a value which is corresponding to a certain film thickness. When the bridge is in the balanced condition, a relay may be energized to activate a magnetically operated shutter to cut the vapor beam. And in this experiment, accuracy obtained in the measured resistance is approximately 0.01%. The accuracy of the thickness value calculated is smaller since it depends on the accuracy of thickness resistance relation which we used. So, these are the electrical techniques used for the thickness measurement in case of thin films. In the next class, we can discuss with another method, quartz crystal monitor, which is most widely used method for the thickness measurement. Thank you.